To round out the sci-fi sales pitch, Musk has even proposed building factories on the moon. I'm not making this up. According to the press release, the plan is to manufacture satellites taking advantage of lunar resources and then fire them into deep space using an electromagnetic mass driver, basically a giant space railgun, a technology that the US Navy spent over $500 million on over a 16-year period with no success. Apparently, the railgun prototype.
A lunar railgun. The US Navy spent $500 million on this technology over 16 years and couldn't make it work on Earth. Now Musk wants to build one on the moon. This is IPO pitch material, not engineering.
Suffered from extreme heat and physical stresses, the types of problems which would be only more of an issue in space. It's not clear to me why a factory on the moon would be more efficient than a factory in even the most remote places on Earth, or what moon resources Musk is planning on taking advantage of. I would imagine some sort of supply chain still needs to be developed there. It is a bold vision, and it represents a massive U-turn for a man who spent decades calling lunar missions a distraction from going to Mars. If you remember, in 2017, he claimed that he would be sending at least 2 cargo missions to Mars in 2022 to find water sources and establish power, mining, and life support infrastructure so that the first crewed missions could follow in 2024. He later reaffirmed this target in 2018 and again in 2020 before the timeline was delayed. Ultimately, building a data center in a desert or a specialized warehouse on Earth will always be cheaper and easier than trying to build them in space.
This is a pattern with Musk. The hardest possible way to do something is always pitched as the most efficient. Tunnels instead of roads, space data centers instead of warehouses in Texas. It only makes sense if you need the complexity to justify the valuation.
Manufacture and launch them from the moon. Andrew McCallop, an engineer who works for a space startup, has built a web-based calculator that allows the cost of an orbital data center to be compared with the cost of an equivalent terrestrial one. It estimates that building a 1 gigawatt data center and running it for 5 years on Earth costs around $16 billion, excluding chips, and an orbital equivalent would cost over $50 billion, so more than 3 times as much. The thing is that building a few data centers in Texas won't justify a $1.75 trillion valuation. For that, you need a sentient sun and a moon